Hello all, I'm Prashanta Saha. Today I'm going to talk about my paper titled Improving the Effectiveness of Automatically Generated Test Suites Using Metamorphic Testing. In the beginning, we'll discuss about traditional software testing. To test a software under traditional software testing, we need to generate test cases at first. These test cases either can be known input or it can be randomly generated input. Then we pass or run those test cases to the software under test and execute them. From the execution, we get the computed output of that test case. Then we compare those computed output with the expected output. If the expected output matches with the computed output, then we say the test case has been passed. Otherwise, the test case is failed. There are some challenges remains while testing the scientific softwares. Absence of Oracle is one of them. Suppose we try to test a precision based calculation software where the expected output is not known or absent, then the Oracle problem occurs. We know Oracle is a mechanism to verify the correctness of the test outputs, and the absence of Oracle can be too expensive to test the software, and it is not practical to apply the traditional testing technique to test the scientific softwares. Metamorphic testing is a property-based testing technique which can alleviate the Oracle problem in the scientific software, but the effectiveness of metamorphic testing depends on two things. One is the quality of metamorphic relations, and the other one is the source test cases. The metamorphic relations refers to the relationship between the input and output of a test case. In metamorphic testing process, at first we identify some metamorphic relation based on the software under test. Then we generate some source test cases. Either test cases can be randomly generated or it can be coverage based test case. There are some popular coverage based test case like line and branch coverage or weak mutation based coverage. Then we construct follow up test cases using the metamorphic relation. After that, we execute the source and follow up test cases with the program under test and compare the output of source and follow up, and then we get the result. In this paper, our motivation is based upon step 1 and 2. In this paper, for our experimental purpose, we have automatically generated test cases which has certain advantages over the manually written test cases, in particular saving human labor and time. But sometimes these automatically generated test cases can contain trivial oracles such as assert statements in JUnit test cases, which can reduce the fault detection effectiveness of these test cases. In this example, we have used power method from LA4j class. This power method powers the given matrix and return the output powered matrix. To generate the test case, we used Upulee tool. Though this test case have 100% code coverage, but the test case oracle or the test oracle here is trivial because it is only checking the dimension of the matrix rather than checking the necessary properties of that matrix. So this test case can or may ignore the necessary properties of the power matrix, so that sometimes the important bug may be remain undetected. So we modify this test case using metamorphic testing, and our metamorphic relation property we used here is multiplication. So we multiplied the test input by itself and generated a follow-up test case. Then we compared the result of these two output of these two test cases and returned the resultant output. Our research goal here is to improve the effectiveness of automatically generated test suits. So we used coverage based and weak mutation based test cases here as a automatically generated test suit. We try to improve their fault detection effectiveness by applying metamorphic testing, and we also tried to identify the effective AMRs which can improve the fault detection capability of the source test suits. To do the experiment, we used 4 different classes from LA4J project, which is based on Java programming language. These 4 classes have done different matrix and vector implementations. To generate the source test cases, we used EvoSuit tool, which generates line, branch, and weak mutation based test cases. Then we generated 16 metamorphic. We identified 16 metamorphic relations manually. Then verified those input-output relationships of metamorphic relation with sample values. Then we ran those MR modified source test cases with automated source test inputs on the original programs and verified the MR properties again. If any metamorphic relation didn't hold for any test input, we excluded that metamorphic relation for that particular input. And to do the fault detection effectiveness, we calculated the mutation score, and also to generate the mutants we used PIT tool. We collected some preliminary result from our experiment. In this figure on the x-axis we have 4 different classes, and in the y-axis we have mutation score in percent. In automatically generated test suite, we have combined line, branch, and weak mutation coverage together. So we can see here that for SRS and LSS class, the metamorphic testing mutation score have an 100% increase over the automatically generated test suite, and for all the classes there are significant increase in the metamorphic testing. And for developer test suite, we can see only for matrix class there is certain increase on the metamorphic testing. This property will be further investigated in our next paper. This experiment shows that MT can effectively improve the fault detection capability of automatically generated test suites, and using this developer test suite as a benchmark has strengthens our claim. In future, we'll do some large scale implementation to prove our claim further, and we'll also investigate the individual performance of MRs. This research grant has been supported by the NSF. Thank you all for listening to this presentation. If you have any queries, please contact via email.